Hi everybody, in this video we're going to talk about approximating irrational numbers. So we're going to talk about how we can figure out what an irrational number's value is approximately, even if we can't pinpoint it exactly. And to do that, we have to understand that for any positive number, for any positive numbers, a, b, and c, if a is less than b, and b is less than c, then the square root of a is also less than the square root of b, and the square root of b is also less than the square root of c. We could also say that the square root of a is less than the square root of b, which is less than the square root of c, because a is less than b, which is less than c. So just to understand the logic there, if I were to say, for example, if I drop a bowling ball on my foot, then I will be in pain. I could say that, but I could also say, I am in pain because I dropped a bowling ball on my foot. So that's sort of like the logic here. If this is true, then this will also be true. But I could also say that this is true because this is true. Okay? So let's take a look at some of these examples over here. We know that 9 is less than 16, which is less than 25. So let's say that our three numbers a, b, and c are 9, 16, and 25. So a is 9, b is 16, and c is 25. Well, if we know that this is true, then we also know that the square root of these numbers follow this pattern over here. So the square root of 9, which is 3, must also be less than the square root of 16, which is 4, because 4 times 4 is 16, and that must be less than the square root of 25, which is 5, because 5 times 5 is 25. So if I know that a is less than b, which is less than c, then I also know that the square root of a is less than the square root of b, and the square root of b is less than the square root of c. And of course, we can see that this is true. We all know that 3 is less than 4 and 4 is less than 5. Now, another way of saying that is, if I know that this statement is true, then another statement that I can make is that 3 is less than 4, which is less than 5, because 9 is less than 16, which is less than 25. Okay, that's like this over here. All right, now let's take a look at another example. So our numbers here, a, b, and c, are 36, 38, and 49. So our a is 36, our b is 38, and our c is 49. Now, what is the square root of 30? Well, I'll say first, 30. We all know that 36 is less than 38, and 38 is less than 49. So far, so good. This is true, right? But if this is true, which is like my a is less than b, which is less than c part, then the square root of those numbers must also be the square root of a is less than the square root of b, which is less than the square root of c. So what is the square root of 36? Well, the square root of 36 is just 6, because 6 times 6 is 36. The square root of 49 is 7, because 7 times 7 is 49. Now, the square root of 38 is not a whole number. The square root of 38 would be irrational. So I'm just going to keep that in this form, and instead of writing a whole number here, which I can't because the square root of 38 is not a whole number, I'll just write 38 and I'll put the square root symbol over it. Okay, so I have the square root of 38 here. So if I know that 36 is less than 38 and 38 is less than 49, then I also know that 6 is less than the square root of 38, and the square root of 38 is less than 7. Or in other words, the square root of 38 is in between 6 and 7. So it would be 6 point something, right? A little bit bigger than 6, but less than 7. All right, so this is an approximation for the square root of 38. Even though I can't give an actual whole number, or even a decimal. Like I can't say it's exactly 6.5 because it's not. I can't even give it exactly as a decimal, but I can still approximate it by saying, well, I know it's in between 6 and 7. It's somewhere in there, okay? And we could also make the statement that the square root of 38 is in between 6 and 7 because 38 is in between 36 and 49. Okay, and keep in mind here, 36 and 49 are perfect squares, but 38 is not. But we can still say that the square root of 38 is in between 6 and 7 because 38 is in between 36 and 49. All right, so now let's use this kind of logic here to answer the following question. The square root of 70 lies between what two whole numbers? So to answer that, the strategy here is we're going to find, I'm actually going to put, instead of the square root of 70 down here, like you see over here I had the square root of 38, but then over here I had just 38, right? I'm going to put just 70 over here. And here's my strategy. Just like over here, how 38 was in between two perfect squares, what I'm going to do is I'm going to try to find two perfect squares that are on either side of the number 70. So over here, I'm going to find the smallest perfect square, which is greater than 70. So there are an infinite number of perfect squares which are greater than 70. But what I'm going to do is I'm going to find the one that's closest to 70. So the smallest one that's still greater than 70, and that would be 81. Now on the other side, my strategy is I'm going to find the largest perfect square, which is still smaller than 70. So there are a whole bunch of perfect squares which are smaller than 70, but I want to find the biggest one that's smaller than 70. So the one which is closest to 70, and that is 64. Okay, so now what I'm going to do is I'm just going to take the square root of 64, which is 8, and the square root of 81, which is 9, and now I have approximated the square root of 70. I don't know exactly what the square root of 70 is. I still don't know that, but I know it's in between 8 and 9. And I know that because 64 is less than 70, which is less than 81. Or in other words, I know that because 70 is in between 64 and 81, which are the squares of 8 and 9. Okay, so we're going to move on now. And by the way, when I say approximating irrational numbers, when we approximate something, it doesn't necessarily mean finding two numbers that are on either side of the number we're approximating, although that's one way to do it. Approximating something really just means finding a number that's pretty close to the number that you're looking for. So for example, the number 3 is an approximation for pi because 3 is pretty close to pi. And any number, going back to this example over here, any number which is in between 6 and 7 would be pretty close to the square root of 38. All right, so moving on. To approximate an expression with an irrational number, just approximate the irrational number first. For practice gaining math sense, try doing mental math first, but you can always use a calculator for greater accuracy. Okay, so now we're going to approximate not just the irrational numbers themselves, but any expression that has an irrational number in it. And there are lots of irrational numbers, but in these examples we're going to focus on pi, which is one that comes up a lot in math, so it's one you should be familiar with, and also the square root of 2. That one also comes up a lot. So pi is 3.141592 blah 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 blah. So it's approximate. If we were to just use an approximation, we could say 3.14, or even just 3 would be an approximation for pi. And for the square root of 2, the square root of 2 is equal to 1.41 something something. You could do it over here. Here's the square root of 2. Okay, 1.414213, blah, blah, blah. So it's approximately equal to 1.4. But if you're doing quick mental math, you could even say that it's 1.5 is a reasonable approximation. Remember, we don't have to be exactly right. So you could even say 1.5 is a reasonable approximation for the square root of 2. Just for the purposes of doing some mental math, 1.5 is usually easier to work with in your head than 1.4. So let's take a look at this first example here. 2 pi is approximately equal to what? And we could get different answers here depending on how accurate we want our approximation to be. So if I just use the number 3 as my approximation for pi, then I would have 2 times 3, which is 6. Okay, so I could say that 2 pi is approximately equal to, remember this squiggly equal sign means approximately, not exactly. 2 pi is approximately equal to 6. I used 3 as my approximation. Pi is actually a little bit more than 3. So really, 2 pi should be a little bit more than 6 since I undershot it, right? So, but I could say if I were to place 2 pi on a number line, I could say since I know it's a little bit more than 6, it's not going to be up to 7 because it's not greater than 3.5. If I did 3.5 times 2, then that would be 7. But I know that pi is less than 3.5, and 3.5 times 2 would be 7. But I know it's greater than 3, and 3 times 2 would be 6. So I know it's got to be in between here somewhere, in between 6 and 7. So we could put 2 pi somewhere around here in between 6 and 7. Okay? Probably a little bit closer to 6 because pi is only 3.14. All right, if I were to make this approximation a little bit better, if I do 3.14 times 2, then that would give me 6.28. So, whoops. Okay, so that would be a little bit closer to 6 than 7. And by the way, this is still just an approximation. I could add more decimal values to the end of it if I wanted to get a greater and greater approximation, but it's always going to be an approximation as long as I have a finite number of decimal places after the decimal point here. Okay, so let's move on to -2 times the square root of 2. Well, I know that the square root of 2 is approximately 1.4. For the purposes of doing mental math, then let's just use 1.5, and I know that the square root of 2 is a little bit less than 1.5, but if I use 1.5 here, then I could do 1.5 times 2 in my head pretty easily. 1.5 or 1.5 times 2 is 3, and then since we're just multiplying by -2 instead of +2, our approximation, a reasonable approximation for this would be -3. But I know that the square root of 2 is actually a little bit less than 1.5. So that, let me just ignore the negative here for a second. Forget that we have this for a second. Okay, since the square root of 2 is actually a little bit less than 1.5, which is what I used for my approximation, I know that 2 times the square root of 2 is going to be a little bit less than 3. It's going to be 2 point something. All right, so it'll be in between 2 and 3 somewhere. But since I know that this is actually a -2 that I'm multiplying by here, I know that the value is going to be somewhere in between -3 and -2. Just like if we ignored the negative for a second, it was between 2 and 3, a little bit closer to 3. When we put the negative in there, it's going to be in between -2 and -3, still a little bit closer to -3. So we could put it over here This is a pretty good approximation for negative 2 times the square root of 2. All right, so let's put it over there. All right, so moving on to the next expression that we have here with an irrational number in it. The irrational number here being pi again, just like it was back here. Now we have pi over 3 plus 6. Well, pi is approximately equal to 3, and 3 divided by 3 is 1. So this term over here is approximately equal to 1, and 1 plus 6 is 7. So pi over 3 plus 6 is approximately equal to 7, but not quite. Now, is this expression really, is it greater than 7 or is it less than 7? Well, pi is not exactly 3. It's actually a little bit greater than 3, right? So that means that my numerator here is bigger than the denominator, so that pi over 3 is actually a little bit more than 1. It's not exactly 1 like I used down here. It's a little bit more than 1. So if I take a number that's a little bit more than 1, and then I add 6, I'm going to get an answer which is a little bit more than 7. Okay, so pi over 3 plus 6, maybe about here is a reasonable approximation on the number line. So let's write that in there. Pi over 3 plus 6, be about there. All right, now we have an expression with both of these irrational numbers in it. We have the square root of 2 and we have pi over here. So 4 times the square root of 2. Remember that the square root of 2 is approximately equal to 1.4. It's a little bit more than 1.4. 1.41 something something something. Just for the purposes of doing mental math, though, let's use 1.5. It's a little bit easier to do in our heads. 1.5 times 4. So we have 1.5 4 times. So 1.5 plus 1.5 is 3. Plus another 1.5 would be 4.5. Plus another 1.5 would be 6. So 4 times the square root of 2 would be approximately equal to 6. A little bit less than 6 in actuality, because I used the 1.5 as my approximation for the square root of 2, but square root of 2 is actually a little bit less than 1.5. So this times this would actually be a little bit less than 6, but let's go with 6 for now. Minus 5 times 5 times pi, and pi is approximately 3. So 5 times 3 is going to be 15. Remember, this is not exactly what this is, but it's pretty close. Pi is actually a little bit more than 3, so 5 times pi would be a little bit more than 15. All right, so we have something which 9 minus 15 would be negative 9. Careful, it's not going to be positive 9. That would be 15 minus 6. But if we go the other way and do 6 minus 15, that's going to give us negative 9. But since in actuality we were doing something which was a little bit less than 6 and a little bit more than 15, then if we start at a little bit less than 6 on the number line and move to the left by a little bit more than 15 spaces, we're going to go a little bit past negative 9 and end up maybe over here somewhere, okay, for our final answer. So it'll be somewhere between negative 9 and negative 10. All right, so I can say that this is approximately equal to negative 9, but not exactly. I'm actually going to be a little bit further to the left on the number line because I started a little bit to the left of 6, and then I moved a little bit more than 15 spaces to the left. So I'm going to end up here somewhere. Okay, 4 times the square root of 2 minus 5 pi would be about here. It can be a little bit dangerous approximating in this way when the coefficients are large, and I'll tell you what I mean by that. So let me just pause for a second and just talk about pi. So one approximation for pi is 3. Another more accurate approximation would be 3.14. It's still an approximation, but it's a little bit better. The difference between 3 and 3.14 is 0.14, right? Now what if I multiply both of these by 2? This would be 6, and this would be 6.28. The difference between these two numbers is 0.28. So my error went from 0.14 to 0.28 when I multiplied by 2. What if I were to multiply by 3? Then this would be 9, and this would be 9.42. All right, and the difference between 9 and 9.42 is 0.42. So now the error has jumped all the way to 0.42. So the bigger the coefficient is, the more the error is going to be. So if I'm using the number 3 as my approximation here, but I know that pi is really closer to 3.14, the higher this coefficient is, the more of a discrepancy there's going to be between my approximation and the actual value. So for something like this, it might turn out to be a little bit more off than the other ones, but it'll still be pretty close. If I give you an exercise to do similar to this in deck toys, then I'll make the coefficients small enough that you can still use these approximations and get away with it. But just keep in mind that when the coefficients are larger, you're going to be off by a larger amount. You can see that if you understand that pi is a little bit more than 3, and if you know that the square root of 2 is a little bit less than 1.5, you can make some reasonable approximations and do a lot of this in your head, as long as the numbers, are using pi or the square root of 2. There are a whole lot of irrational numbers, obviously, and I don't expect you to know all of them. I don't know all of them. I really just know the pi and the square root of 2 approximately off the top of my head. But we could, if you wanted to, go to a calculator just to get a more, obviously this is going to be a whole lot more accurate. So 2 times pi, let's see how good our mental math was. 2 times pi, 2 times, this doesn't have a pi button, I'll just use 3.1415. So 6.28, so we put it over here on the number line, so that was pretty good. All right, -2 times the square root of 2. Let me do the square root of 2. I want to put this somewhere. You know what, let me erase this for a second, so that that's not in the way. All right, so let's see how good this approximation was. The square root of 2 is that, okay, and then times -2. Let's just multiply it by 2, and then the answer will be negative. Okay, so approximately -2.82. So what did we say? We put it over here, which is pretty close to -3, but not quite. It's still on this side a little bit, which looks like a good approximation. All right, -2.8 something. All right, so that was pretty good. What about this one over here, pi over 3 plus 6? Well, let's do 3.1415, which again is not exactly equal to pi. That itself is an approximation. All right, but we're going to divide that by 3 and then add 6. And we get a little bit more than 7. Okay, so this seemed like a pretty good place to put it on the number line. A little bit more than 7 there. And finally, we have 4 times the square root of 2. On this simple calculator, it's a little bit difficult to do an expression like this. Okay, so now let's go ahead and do 4 times the square root of 2 minus 5 pi in the calculator. See how good our approximation was. All right, so I'll do 5 pi, I don't have a pi button, I'll just use 3.1415 for pi and then times 5. Okay, and that's, even that itself is an approximation, but that's all right. So 5 times pi is about that, and we'll hit the M plus button to save it, and then we'll do 4 times the square root of 2. So the square root of 2 is that, and then times 4 equals that, and then I have to subtract the 5 pi, which I saved earlier. So minus, and then I can click on this, and that was the number that I had. Okay, and so my answer is negative 10.05. So we can see that we were a little bit off. Notice I'm using the word we here, which maybe is not fair, because I've been doing all of this, but I'm putting the blame on all of us collectively. Anyway, our mistake was that we used 3 as our approximation for pi here, but like I said earlier, when we have a relatively large coefficient, then the error is going to be greater. So we put the answer between -9 and -10, or I put the answer between -9 and -10. In fact, the answer would be a little bit further to the left of -10. So it would actually be, if I extend this a little bit, somewhere between -10 and -11, but still very, very close to -10. So we were off by a little bit. Again, our approximation was not too bad, but we did put it between the wrong 2 integers. It's really between -10 and -11. Again, if I give you a problem like this in deck toys, I will use smaller coefficients so the error will not be too great, so that you can use 1.5 as your approximation for the square root of 2, and you can use 3 or maybe a little bit more than 3, like 3.1 or 3.14 as your approximation for pi, and still get away with it. Really, I should say you can use 1.5 for the square root of 2 as your approximation, but then understand that it's going to be a little bit less than that, because really it's, again, the square root of 2 is really about 1.4. So you can use 1.5 for the mental calculations real quick, but then understand that whatever you get, it'll be a little bit less than that. Okay, or, not to get too confusing, but if it ends up in negative territory, then a little bit greater than that. But anyway, let me just, with the final portion of this video, we're going to do some IXL. Okay, let's do IXL 8th grade F. Checkpoint. Approximate irrational numbers. Here's the first question. Complete the following statement. Use the integers that are closest to the number in the middle. They're saying that are the closest to the number in the middle, because I could say that the square root of 52 is between 0 and 1,000,000. That would be correct, but we want to get a little bit more accurate there and use the whole numbers that are closest to the square root of 52. And here's a strategy. So I'm going to write down here 52 is in between which 2 perfect squares? Well, over here I could say 49, and over here I could say 64. Those would be the perfect squares which are closest to 52. And the square root of 49 is 7, and the square root of 64 is 8. So I know that the square root of 52 is in between 7 and 8. Okay, we're going to do the same thing here, so let's see. This would be perfect square, which is closest to 21. How about 16 on this side and 25 on this side? So the square roots of 16 and 25 are 4 and 5. So the square root of 21 is between 4 and 5. It's not letting me jump a level. Okay, but it is giving me a different kind of question here. Which numbers are between the square root of 11 plus 3, oh boy, and pi plus 3.14? All right, so here's how we're going to do that. The square root of 11 plus 3. Let's do the same thing that we did for the square root of the other numbers. We'll say that the square root of 11 is, let's see, here we could say 9 is a perfect square on that side and 16 on that side. So that would be, I know that the square root of 11 is going to be between 3 and 4, which means that the square root of 11 plus 3, if I know that the square root of 11 is between 3 and 4, if I take the smaller of those two numbers, 3, then 3 plus 3 is 6. And if I take the bigger of those numbers, 4, then 4 plus 3 is 7. So I know that the square root of 11 plus 3 must be between 6 and 7. And let's see. Oh, and then I also have to do pi plus 3.8. So I know that pi is a little bit more than 3. Let's use 3.14. And you know what? Let's just go ahead and add these two. So 3.14, whoops, 3.14 plus 3.8. So it's about 3.94. Okay, so, nope, oh my gosh, you didn't see that. About 6.94. So I know that the square root of 11 plus 3 is between 6 and 7, so 6 point something. And this expression, pi plus 3.8, is also 6 point something. It's 6.94. Okay, so what do we have so far? We want to know which numbers are between this, which we know is between 6 and 7. So let's just, for now, let's put 6 point something. And it's probably a little bit closer to 6 than it is to 7, because 11 is much closer to 9 than it is to 16. But so far all we know is that the square root of 11 plus 3 is 6 point something. And we know that pi plus 3.8 is about 6.94. So I want to know which of these numbers are between 6 point something and 6.94. And at this point, it behooves me to really learn what this expression is a little bit more accurately. So at this point, you could just go to a calculator and let's get a better approximation of the square root of 11. So that is let's say about 3.3. So plus 3 is going to be 6.3. Okay, so really we're trying to figure out which of these numbers are between about 6.3 and about 6.94. And yes, you could use a calculator to help you with this. You can see I just use a calculator. I recommend trying to do as much of it as you can without a calculator, just to practice your mental math. We could go even further, and there are ways that we could have gotten a better approximation of the square root of 11 plus 3 without using a calculator, but you know, it is very time consuming. So yes, I do recommend using a calculator for some of this, but try to do as much as you can mentally. So 61 divided by 10, I know that's just 6.1. If I'm dividing something by 10, I just take the decimal point and move it one space to the left. So that would give me 6.1, which is less than 6.3. So it's not going to be between these two values. So I'm not going to click on this one. What about 13 pi over 6? Well, pi over 6, I know that pi is a little bit more than 3. And I know that 3 over 6 is a half. So if I have something which is a little bit more than 3 over 6, that's going to be a little bit more than half. So I have 13 times something which is a little bit more than a half. Well, half of 13 is 6.5. So this should be a little bit more than 6.5. So it seems reasonable that it would be in between these two numbers. So I am going to check that. And you could double check your answer in the calculator. So 13 times pi I'm just going to use 3.1415, okay, equals that, and then divided by 6 is 6.8. So yes, it is between these two numbers here. The square root of 45, let's see. So we're going to use that, what we were doing before. We're going to find two perfect squares on either side of 45. So we could say 49 over here, we could say 36 over here. So I know that the square root of 45 is between 6 and 7, probably a little bit closer to 7 because 45 is so much closer to 49 than it is to 36. So it does seem reasonable that the square root of 45 would be in between these two numbers here. And we could just check that with a calculator. The square root of 45 is 6.7, which is between these two numbers. Now 6 and 1/9. You shouldn't need a calculator for this because 1/9 is just going to be 0.1 repeating, right? So it'll be 0.1 repeating. So 6 and 1/9 would be 6.1 repeating, which is still less than 6.3. So this would not be in between these two numbers. And then the square root of 83 minus 3. Let's see about that. Let me switch to blue here. So the square root of 83 will be between what two whole numbers? Well, 83 is between 81 and 100. Those are the nearest perfect squares. Square root of 81 is 9. Square root of 100 is 10. So the square root of 83 is between 9 and 10. And then the square root of 83 minus 3, if I take the lower number here, then 9 minus 3 is 6. And since the square root of 83 is greater than 9, I know that the square root of 83 minus 3 must be greater than 6. If I take the bigger number here, 10 minus 3 would be 7. Since I know that the square root of 83 is less than 10, then the square root of 83 minus 3 must be less than 7. So this is going to give me a number somewhere between 6 and 7. So that's not enough to tell me if it's specifically between 6.3 and 6.94. It could be 6.2, it could be 6.95, it could be 6.5. Right now we don't know. This is not enough analysis to say for sure. Now the square root of 83 is much closer to 81 than it is to 100. So the square root of 83 is probably something very small like 6.1 or maybe 6.2. And then so like maybe 9.1 or 9.2, and then when we subtract 3, maybe 6.1 or 6.2. So my guess, and I might actually not be right about this, is that it would be a little bit less than 6.3, so not between these two numbers. But still, for this one, let's just use a calculator there, and we'll do the square root of 83, okay, minus 3. Yeah, 6.11, so it is a little bit less than 6.3, so it's not between these two numbers, so we're not going to click that one. So the only values here which are in between these two expressions here, which we approximated in these two numbers, are these two over here. So that's it. All right, and now we have some more number lines. Which point on the number line, that was a tough one. They're not all that tough, but yes, it is a lot easier if you use a calculator, and I recommend trying to do some mental math, just to challenge yourself to get, some more math sense. But yes, you can use a calculator to help you. Which point on the number line shows the position of 4 pi plus 2? Well, I know that pi is approximately equal to 3. So if I plug 3 in for pi, then I'll get 12 plus 2, which is 14. But my approximation was 3. I know that pi is actually a little bit more than that. So 4 pi plus 2 should actually be a little bit more than 14. So D is the only one which was reasonable here. All right, so you really didn't need a calculator for that one. That one you should be using just mental math for. Okay, determine whether each comparison is true or false. All right, so pi over 3. Pi is a little bit more than 3. So if I have something which is a little bit more than 3 in the numerator, and then I have 3 in the denominator, this fraction is going to be bigger than 1. And 2/3, which is a proper fraction, the numerator is smaller than the denominator, is less than 1. So is it true that a number which, and by the way, this inequality symbol here with the mouth part being next to pi over 3 and the pointy part being next to 2/3 is telling me that this number is greater than this number. Well, if I know that this number is a little bit bigger than 1, and this number is less than 1, then yeah, it makes sense that this number is greater than this number. So we are going to, without using a calculator, we can click on true there. Now what about this over here? Is the square root of 3 greater than 2.2? Well, the square root of 3 would, let's see, so we have, what perfect squares are on either side of 3? It would be 1 on the left and 4 on the right. Okay, so the square root of 1 is 1. The square root of 4 is 2. So the square root of 3 is somewhere in between 1 and 2, but it's definitely less than 2. So it does not make sense that the square root of 3 is greater than 2.2, which is already greater than 2. So no, we're going to click false for this one. All right, and now we have the square root of 48. So what two whole numbers would that be between? Well, I have perfect square of 49 on the is greater than 48, and then on the other side 36. So I know that the square root of 48 must be between 6 and 7. So does it make sense that it's less than 8.1? Yeah, that makes sense. So let's click on true for that one. And then, okay, so we have for the last one, square root of 99 is between, well, 99 is between 100 and 81. Those are the nearest perfect squares. Okay, so the square root of 99 is going to be between 9 and 10. It's actually going to be very close to 10 because the 99 is so close to 100. So anyway, I have something which is very, very close to 10. So actually, let's just approximate that. Let's say that 1 over the square root of 99 is approximately equal to 1 over 10. And 1 over 10 is 0.1. And 0.1 is greater than 0.05. And in fact, 1 over the square root of 99 is a little bit more than 1 over 10. How do I know that? Because anytime I take a number and I divide it by something, and then I take that same number and I divide it by something which is smaller, I'll get a bigger answer. So just as a completely separate example, if I take the number, I don't know, 20 and divide it by, let's say, 5, then I get 4, right? If I take the number 20 and divide it by something smaller than 5, let's say 3, then I'll get an answer which is bigger than my previous answer. Okay, so since the square root of 99 is a little bit less than 10, when I do 1 divided by 10, I'll get 0.1. When I do 1 divided by the square root of 99, I'll get something which is a little bit bigger than 0.1. So if 0.1 is already bigger than 0.05, then 1 over the square root of 9, which is even bigger than 0.1, would certainly be bigger than 0.05. So for this one, I can also click true. All right, so we have another one like this. Determine whether each comparison is true or false. Okay, so 8 pi is, I know that pi is about 3. 8 pi, 8 times 3 is 24. 8 pi is going to be a little bit more than 24 because pi is actually a little bit more than 3. So 8 pi is definitely going to be more than 23 and 1/8, or 23.375, because 1/8 is 0.375 in decimal form. But that doesn't even matter because I already know that this is bigger than 24, so it's definitely bigger than 23 and some fraction. So we're going to click true for this one. 5.8 repeating. So 2 times pi is, well, 2 times 3 would be 6. So 2 pi is a little bit more than 6. And 5.8 repeating, even though the 8s go on and on and on and on forever, this number is still less than 6. So I have something which is less than 6 over here, and I have something which is greater than 6 over here. So there's no way that this number would be smaller than this number. So we're going to click false for that one. The square root of 51. So let's see here. I know that 51 is between 49 and 64, which means it's between 7, the square root of 51 is between 7 and 8. And for this one over here, I know that 49 divided by 7 would be 7, right? And here I have 48 instead of 49. So if my numerator is a little bit smaller, then the fraction overall will also be smaller. So this has got to be a little bit less than 7. So I have something which is a little bit less than 7 on the right. And on the left, I have something which is greater than 7. It's between 7 and 8. So yes, this number would be greater than this number. So we'll click true there. And let's do the last one. So the square root of 2, I think we did this before, right? So the perfect squares that 2 is in between are 1 and 4. So the square root of 1 is 1, the square root of 4 is 2, the square root of 2 is somewhere between 1 and 2. So it does not make sense that it's less than 0.1, okay, because it's already greater than 1. So it can't be less than 0.1, which is, right, 0.1 is less than 1. So the square root of 2 is greater than 0.1, not less than 0.1. So we're going to click false for that one. I'm in the challenge zone. Okay. Put the following numbers in order from least to greatest. All right, so we have let's just, as an approximation, we'll use 3.14. And then 3.14 minus 1 would be 2.14. I know a lot of you are thinking 3.14 minus 1 is 3.13. Line up the decimals, people. 3.14 minus 1 is 2.14. So this is about 2.14. 7 fourths is just 1 and 3/4, right? So 1.75. The square root of 8, let's see. 8 is between 9 and 4. Those are the nearest perfect squares, so between 2 and 3. All right, so I know that the square root of 8 is greater than 2 and less than 3. All right, and then I have 1.1 repeating, is just 1.1 repeating. Okay, so these are the 4 numbers that I have. Out of these, the smallest one is 1.1 repeating. So let's put that over here near where it says least. The next biggest one is 1.75, so 7/4. And then it's between pi minus 1, which is about 2.14, and the square root of 8, which is between 2 and 3. So this right here is not enough information for me to tell which one is bigger, because this pi minus 1 is 2 point something, and the square root of 8 is also 2 point something. It's between 2 and 3. So how can I compare these? Well, 8, what did I say before when I said that this is between 2 and 3? How did we get that? We got that because we said 8 was between 9 and 4, and 8 is really between, if I have to decide between 4 and 9, 8 is much closer to 9, right? So the square root of 8 should be closer to 3 than it is to 2, which means it's 2 point some relatively high number after the decimal, as opposed to 2.1, which is pretty low. So this is going to be my biggest number, but if you're not sure about that, then you can use a calculator. You could say the square root of 8 is 2.8 something. So it's definitely bigger than pi minus 1, which is about 2.14. So that's going to be the order there. The square root of 8 is the biggest here. So let's submit that. Okay, another one of these. These are not too bad, actually. We've done this kind of thing a million times. The square root of 22. So the nearest perfect squares are, let's see, 25 and 16. Square root of 16 is 4. Square root of 25 is 5. It's between, so the square root of 22 is between 4 and 5, so this makes more sense over here. So I think the last one also said point D when we had a number line, but whatever, that's just a coincidence. Okay, what integer is between the square root of 7 and 6 pi over 5? All right. So the square root of 7, let's take 7 itself, is between 9 and 4. So I know the square root of 7 is somewhere between 2 and 3. Those are the square roots of 4 and 9. And let's see if we can do some reasoning over here. So pi is, yeah, well, anyway, 6/5. So 6 over 5 is a little bit more than 1. And so if I, yeah, so pi is approximately 3. Let's say it this way. 6 pi over 5. So it's like I'm taking pi and I'm multiplying it by 6/5. 6/5 is a little bit more than 1. So if I take pi and I multiply it by something which is a little bit more than 1, then I'll get something which is a little bit more than pi. So 6 pi over 5 is greater than just pi itself, and pi itself is greater than 3, right? So 6 pi over 5 is definitely greater than 3, and we just learned that the square root of 7 is less than 3, so the integer that's in between the square root of 7 and 6 pi over 5 must be 3, okay? Because let's just write this all in one line over here. This is really the important part. The square root of 7 is less than 3, but 3 is less than 6 pi over 5. If you're worried that here I had 3 on the right of 6 pi over 5 and here I had 3 on the left of 6 pi over 5, just pay attention to which to the inequality symbols. The mouth part is next to the 6 pi over 5, so this is greater than 3, and here again I put the mouth part next to 6 pi over 5. So I'm still being consistent here. So 3 is in between these two numbers here. Okay, which two numbers is the square root of 4.5 of 45 between? All right, so while I can get the whole numbers easily, and then it's going to take a little bit more work to narrow it down even more in decimals. So anyway, well, since it's only given me options that are between 6 and 7, I know I'm going to get between 6 and 7 here. But just for completeness sake, let's do it. So I know that the square root of 45 must be between, these are the squares that are closest to 45. So square root of these numbers are 6 and 7. So I know that the square root of 45 is between 6 and 7, but that doesn't help me so much for this problem because all of the answer choices that it's giving me, all the numbers are between 6 and 7. So I can't immediately eliminate any of them. But what I can do, and let's just use a calculator for this one. What we can do, well, there are a couple of ways that the calculator could help us. I'm going to do it the hard way first. So 6.1 squared, so 6.1 times 6.1, or you could also use this little button here if you have it. Whoops. 6.1 times 6.1 is 37.21, and 6.2 squared is 38 point something. Now, at this point, I could say that if it were the case that 45 was between what I got before, 37, what did I get before? 36.21, right? 6.1 squared, 37.21. So if it was the case that 45 was between 37.21 and 38.44, which is the other number I got, then it would also be the case that the square root of 45 would be between 6.1 and 6.2. But obviously 45 is not between these two numbers. 45 is not less than 38. It's not, well, it is greater than 37, but it's not less than 38. So this is not necessarily the case, and in fact it's not the case because I know that 45 is actually greater than 38.44. So I can switch these around over here. Then I want 45 over here, which means that the square root of 45 is actually greater than both of these numbers. So it's not in between these two numbers. Now I could continue on in this fashion for all of these. But you're probably thinking to yourself right now, well, wouldn't it be easier just to put the square root of 45 into the calculator and see which one it lies between? And yes, you're right. So let's just do that. So just type 45 and then hit the square root button. So it's 6.7 something. So it's greater than 6.7, but less than 6.8. So it's between those two numbers. Awesome. Okay. And that is it. So I hope that was helpful, and have a great day.